more time. So, by parts. Let's do the recurrence relations today. So what happens with recurrence relations is that they start to repeat. So we're going to start with question 5, even though we probably had done that one or a similar one last week towards the end. We'll start off with that one and see how we go. Okay, so it does say by using 2 applications of integration by parts, evaluate the integral from 0 to pi on 2 of e of x cos x dx. Before we start, we need to have this acronym. We've got to follow this acronym. It does help, and it tells you which one you should differentiate first. That's the idea. So then we had u, and we had du, and we had dv, and we had v. When we are writing our u and dv, these components here must be all of this. And then the way we're going to write our integral, our I. So let me just say the way I would write this, and this would help for our reduction formula. You're asked to evaluate this, right? Last week I was just writing equals. I think it's better to get used to writing I equals this, let's say. So I is I just stands for integral or integration. So I is this thing. So instead of writing this thing out every single time, we just write I equals. Just a bit easier to work with. So yeah, so your u, you can choose because you've got trig and you've got an exponential. So it doesn't really matter which one you're going to differentiate. Yes, you can differentiate trig first. It really doesn't matter. What I'll do is I'll try to see what happens here. Maybe y dash is going down, going up is integration. So you can tell if you were to differentiate cos, you're going to get negative sign. Maybe to avoid that, you might have done dv as cos x and then differentiated the exponential. Any questions about that firstly? It doesn't really matter even if you did it the other way around for these two, because you know they don't become anything. So exponential, differentiate that, that becomes ex dx, right? When we have a d, we have a d. Cos x dx, when we integrate cos, goes up to just a sine x. And then the idea was, think of it as a tick. So those two, take away those two. So it will be ex sine x. And then because you've got limits, this will have your limits already. Right? This is technically been integrated. That's the way you got to think about it. Minus the integral of these two put together. Ex sine x dx with your limits from 0 to pi on 2. Okay. Then what we did, obviously, we would have subbed in our limits here. So sine of 90 degrees should give you 1. Sine 90 is 1. So your first answer is e pi on 2. And then sine of 0 is just 0. So that cancels out. There's no need to minus 0. Then you're left with this thing, minus integral pi on 2, 0, ex sine x dx. Okay, now that isn't any more helpful than the question originally, right? But we realized last week, we said, okay, we've got to probably do this again, a second time. So we'll say u equals, you have to try to keep them the same. So you can't go u equals sine x, otherwise you're just going to revert back to the question. So you'll say u equals ex, and then again, du equals ex dx, dv equals sine x dx, and of course, the integral of sine right here becomes negative cos. And then you just do it all again. Equals e pi on 2. And look at my setting out. Right? So when you guys are writing it, you got to set it out the same way. So when I'm dealing with this integral, I've left my u on this side here. So then when I'm trying to rewrite it, I can just go look up here, bring this down all the way. It becomes equals pi on 2 minus this integral. So open big brackets, these two put together. So that would be negative ex cos x, and then in brackets pi on 2 and 0 minus these two, right? So the integral of 0 to pi on 2 negative, which makes this into a positive, ex cos x dx. Any questions for me just at this point? Everyone's keeping up. Great. Now, if you remember from what I said also last week, I said if you get a plus here, that's a problem because we know we're going to bring this to the other side, and that's going to subtract. But that's why there's a negative here. Now make this into a negative. So let's just keep going. Equals pi on 2. Remember, this is still I, so I equals minus, and then maybe big brackets, sub in pi on 2. So cos 90, that should give us 0. So this time you're going to get 0 minus, sub in 0 for cos, so cos 0 is 1, and then e to the 0 is 1, so this one becomes negative 1. Lots of room for error there. So subbed in 90 into here, that gives me 0, so that I'll just put 0, minus the second limit. So minus sub in 0, so negative e to the 0 is negative 1 times 1 is just negative 1. Plus, now can you guys see how that, like I said, is this, right? That is exactly the top one. So to make your math just look a little bit nicer, instead of rewriting this out, what are we going to write? We're going to write our letter, I. Right? Why do you want to rewrite this? Because you're not going to go ahead and integrate that. So again, I equals this. So let's replace that for I. All right, next line. E pi on 2. That's plus 1. So minus 1. Whew, lots of room for mistakes, right? And then minus I. So I think the rule usually is if you can do integration by parts, then you pretty much can do all of math. Because if you make no mistakes here with your negatives and stuff, that means you're pretty much a pro. So this is the one. Over 2. All I did was bring the minus I to the other side, 2 times the integral. Therefore, your integral is this. You're done. This will be worth 4 marks to 5 marks. But we'll just say 4 marks for now. Zoom out. Ask me any questions you've got. These type of integration by parts won't be in the speed tests. So these are not asked at the beginning of the paper. These are only questions, questions 6 and 7, so towards the end. And just so you're aware of it, this has been in the HSC maybe, I would say maybe 5 out of the last 15 years. So that's a 1 in 3 chance of just getting this exact question. You know, so how can you say 4 units hard when you already know the question you're going to get? You don't have to memorize a whole bunch of this stuff, which isn't too complicated. It really is not that hard. Your algebra has to be perfect, so I can't deny that. The algebra needs to be spot on, but otherwise, yeah, a lot of the stuff gets pretty straightforward. All right, anyone still copying down? All right, let's try another one. Not yet. we'll do one more of these ones, and then I think we'll do some of the inverses. Okay, let's try this one. Use integration by parts to evaluate the integral of x squared sine x dx. Okay, so of course you would just go ahead and start. You know, you don't need to even think if they're going to be, you know, reoccurring or not. That's not a problem. It's not something you're trying to look out for. It's not like a log where you've got to keep your eye out. Oh, is this a log, or if it isn't a log? It's not like that. You just start, you know, and if you come up with the problem, you try to solve the problem. So again, we'll just say I is this. It just saves you time in writing it over and over again. You can just write I equals. Then you'll know your U, du, dv, v, u. Okay, Lieti, we're going to go for algebra then trig. So this time we're going to go with x squared here, and that becomes 2x dx. dv becomes sine x dx, and then, just so we don't get it wrong, the integral of sine is negative cos. Equals. These two multiplied, so that becomes what? Negative x squared cos x with our limits, minus these two multiplied. So that's a negative, which makes this into a plus. That's a constant 2. I can keep that in the outside, and then I've got my limits. And then again, I think about it, I'm like, great, I reduced it by 1, but this is still here. That's annoying. So I would go, oh yeah, I probably have to do this again, right? So maybe put this bit into your calculator. Cos 90, again, should give us 0. And then when you put in 0 for cos 0, that gives you 1. But then this is going to be 0. 0 times 1 is still 0, so this bit's just going to end up becoming 0. Don't you love those questions? Go on. You don't even have to worry about it. And then u, again, keep it the same. Algebra, you've got to choose algebra first. du equals just 1 dx. dv equals cos x dx. V, integral of cos is sine x. Do that tick. Here we go. So 0, so don't worry about it. 2 times these two together. So x sine x, pi on 2 and 0. Right, big brackets here because it's 2 times a lot of things. Minus the integral of sine x dx. Any questions? Okay, is this a repeating question? Yes or no? Is this a repeating question? Did this reoccur? No. See, there is no x squared. So this is not a repeating question, but it is a integration by parts twice. So we call that a recurrence, but it's not a repeating style of integration. The repeating would be if that was specifically x squared. And those repeating ones, you'll realize, usually only happen with the exponential there, because the exponential is not going to get reduced, right? Whereas this one got reduced. So you're not going to bring this over or anything like that. You can actually integrate just sine x. The integral of sine x is just negative cos. But anyways, so next line, 2, big brackets. All right, sine 90. Sine 90 is 1. Sine 90 is 1, so then that becomes pi on 2 times 1, which is just pi on 2, minus 0. So just, no, 0 if you want to write that. Minus, again, the integral, well, there's two ways of looking at it, but I think it's probably easy to say negative for now. The integral of sine. Integral of sine is negative cos. So negative cos x. And then again, pi on 2, 0. We're almost there, you guys. 2, don't expand yet. Pi on 2, minus, okay, now, big brackets. Okay, so big brackets even in here if you want. Negative cos 90. Cos 90 is 0, so negative cos 90, which is 0. I just want to do that so you guys can see what I'm doing. Minus, and then again, minus cos 0. Cos, so minus cos 0. That closes that one, and then that closes that one, and then you've got your big brackets. So a lot of room for error with all these negatives. Can't keep saying that to you guys. Cos 90 is 0, so that's gone. Cos 0 is 1. That becomes negative 1. That becomes positive 1. That becomes negative 1 again. So the answer is 2 times pi on 2, which is pi, minus negative 1 times 2 is 2. So I haven't seen many students seriously get this bits wrong, like your integration by parts or anything like that. That's usually, like, I haven't seen many of my students ever get these bits wrong. They get pretty comfortable with that. I have seen a lot of them repeatedly get this section here wrong because they're not careful with their math. They're careless about it. Oh yeah, whatever, I can get it right. But a lot of room for error. So just take your time here. No one's going to rush you at this stage. Just use your calculator, use your brackets, and there it is. Whatever works well for you. Okay. Still copying? Anyone still copying actually? All right. One more like it, those normal recurring ones, and then I want to look at these harder algebraic ones. Let's do EX sin X. So I can fit it into there. Let's see how we go. Write that down. Maybe I'll give you a minute just to write what you would have written. Have a think about it. What should your U be, your DU be? All right, so U is E of X, dV is sin X dx, or you could have done the other way around. It doesn't matter, so don't think, oh, okay, for this one it does not matter, because it doesn't make it any easier or any harder, either way. V equals the integral of sine is negative cos, so maybe you should have done it the other way around, would have been a little bit smarter, but I know you can't avoid it. So negative cos, and then du is just EX dx. So I'll just save myself a line. Let I equals to this. So therefore I equals negative, we don't need brackets because there's no limits. So negative EX cos X, and then minus plus EX cos X dx. And you know it, just do it again. Don't hesitate. du equals EX dx. dV equals cos X dx. V equals integral of cos is sine. Next line equals negative ex cos x plus this. When there's a plus sign, hey, it's even better, right? I don't need to write my big brackets. Ex sine x minus integral of ex sine x dx. And I know I've done it right because I've got a negative here. So when I'm going to plus it over here, it's going to be I plus I. So 2I equals this. I'll just rearrange to make this positive. And then, of course, you know what I'm going to do. Divide by 2 all over 2. Three marks. That one. 3 marks. Because there's no limits.
Sam, on your last line, how did that plus turn into a negative?
How did that plus turn into a negative?
No, yeah.
All right. Well, that's a plus because of this plus here. But
Okay.
you know that the formula is u times v.
Yeah.
And then?
Oh, yeah. Okay.
Minus v times du.
Yeah.
But I was saying the fact that that's a plus, I don't need to use big brackets because I know a plus doesn't do anything to my operations. It's the negative that's annoying. So up here,
I didn't really see it.
Yeah. No, that's fine. That's fine. Cool. All right. Pretty much is reduction formula. I can pretty much teach you guys reduction formula now, and you'll just understand it from where you're at. But I don't want to just yet. Let's have a look at some, I guess, miscellaneous style of questions. The ones that usually get students. I want to do inverses as well. Yeah, let's do an inverse now. Let's do this one. Okay. Let's do inverses. Before I can do inverses, do we remember our inverse derivatives? So what was what would the integral be so that the answer becomes inverse tan? Does anyone remember? Or other way around? What the derivative of an inverse tan was?
Like
1 on something?
1 on x minus a. X squared minus a.
X squared plus.
Oh, okay.
Inverse tan is plus. You're talking about the inverse sine and inverse cos. And do you want to try it? 1 on?
Root x squared plus a.
Minus,
and the other one is plus.
And I think it's a squared minus x squared.
Yeah.
I don't think it's x squared minus a squared, right? Inverse sine. I'd rather not get it wrong.
1 minus x squared.
Say it again. 1 minus x squared?
Yeah.
Yeah, so it's a squared minus x squared. Correct. Or 1 minus x squared. I thought so. Cool. So yeah, that's that. And then if it was inverse cos is exactly the same as just a negative. So negative 1 on square root 1 minus x squared. All right, that's that. All right, we have to use integration by parts for x inverse tan x. Again, we follow our Laïety, which means we have to, for inverse trig I, we have to differentiate first. So as much as I'm going to hate the fact that I have to increase x, too bad. You can't do anything about it. You have to increase your x to x squared. Right, because you can't integrate inverse tan. The only way you can integrate inverse tan is to use integration by parts. There is no other way you can integrate inverse tan x. So let's do this. So we're going to go u equals inverse tan x. du equals 1 on x squared plus 1 dx. dv equals x dx. V equals x squared on 2. Okay, any questions? All right, so, I mean, again, just imagine this was I, let I equal to this, so I'll just say I equals this times this, which is x squared inverse tan x on 2. X squared inverse tan x on 2. Minus, you can take the half out if it's easier for you. Integral, keep the x squared on the top over x squared plus 1 dx. Okay, this one, not a problem. That's tick. This, x squared on x squared plus 1. You haven't been exposed to this just yet. If you've done your homework, and you have been doing your homework, you would have seen it. I'm just going to assume that you haven't exactly got up to this bit. Now, the only way you can integrate this style, and I think that's a good one to put in your formula sheets or whatever you guys are keeping the track of right now. If your powers of your x's are the same, so if it was less, say, what's the derivative of the bottom? 2x, which is x, so that would be a log. If it was just dx, or just 1 dx or whatever, that would be inverse tan. But if they're the same, so if it's x squared, it's the same power, it's actually what I just call plus 1 minus 1 trick. Now, it doesn't mean you have to always do plus 1 and minus 1. You could plus 2, minus 2. You can plus anything and you can subtract any number. You can, in fact, multiply and divide by anything. You haven't changed it. So this is what's called a plus 1 minus 1 trick. Now, you might think you're doing nothing because obviously you are adding 1 and then subtracting 1. But you're doing a world of difference to your math. Okay, so just keep it in mind, if your powers are the same, plus 1 minus 1 trick. They don't come often, but when they do, they usually stump a lot of students. Next line. And you'll start to realize when these come, i.e. inverse tans and stuff like that. Like, as you do more and more of your questions, you'll learn it. All right, x squared plus 1. The reason why we are plusing 1 is so that these two become the same as your denominator. So of course, x squared plus 1, I can split them up now as a common denominator. There it is, minus 1 on x squared plus 1. See what I was able to do now? By adding 1, subtracting 1, I was able to split up my denominators. Rewrite that all again. Minus a half. Okay, what's x squared plus 1 on x squared plus 1?
1.
1. Minus 1 on x squared plus 1. And I think now we can actually integrate. So watch this. Ugh. All of that on 2 minus half. All right, what's the integral of 1? What's the integral of 1 on x squared plus 1? Well, the integral of 1 on x squared plus 1 is inverse tan x. And now, of course, plus c because there's no limits. And you're done. So that was I guess a harder version of by parts, and the reason why it's harder is because of the inverse trig. There it is. So that plus 1 minus 1 is something you got to watch out for. And that works even if it was like this, just so you guys are clear. You just plus 2 minus 2. Right? So you're forcing it to become the denominator. Okay. Any questions about how I split up everything now? Because that one makes sense, but how about everything else? Okay. Let's try another one. Inverse tan cos x. Use integration by parts to show this. So let's try that one. There's another miscellaneous one. We didn't do this one last week, did we? Should have crossed the questions out. All right. Use integration by parts to show the integral of ln x all squared dx becomes this. All right. Who wants to try this one with me? U, du, dv, v. Come on. Someone just... No, nobody. What would u be? Then maybe I'll start it off. What would u be? Definitely dv can't be ln x all squared because that is what you're trying to integrate. So you can't say, oh yeah, let's put that one as dv. So obviously, what would u be? Yeah. Yep. What would u be?
Either just ln x by itself or 2x ln x.
2x ln x. No, it has to be. Where'd you get the 2x from?
Oh wait, never mind, we're working on left-hand side.
Yeah, it'll just be ln x all squared. And then what would dv be? Not yet, let's do it together. dx. Let's do it together. Now, I just want to make a point because I feel like this might look similar to what we were just doing with logs. Be careful. This one here is not this one here. So this is log of x squared. You're allowed to bring the 2 down. This is the whole log that's being squared. So first you've logged the x, then you've squared the whole number. Be careful, these two are not the same. So you're not allowed to bring your 2 down. All right, anyways. Where are we? du. All right, differentiate this. Mariette, what are you going to say?
2 ln x.
2 ln x times? What are you meant to always times by? Just tell me what you're meant to times by and I'll do it.
The derivative of the inside.
Good job. So derivative of a log x is just derivative of x, which is 1 over the x. That's looking familiar by now, isn't it? 1 on x? Yeah, and then dx. V, what's the integral of 1 dx?
X.
X. All right, done. Next line. I equals to x ln x all squared. Look, you've already got it. X ln x all squared minus the integral of this times by this. What do you see cancels out?
The x on the bottom.
Yeah,
so
right.
The dx.
Yep, so that's that and gone. So you're just left with 2 and then ln x dx. Now you've got a question that says, let's integrate log. You're like, wait, but I can't integrate log. The only way I can integrate log is to do by part. Again, yeah, that's it. So u equals ln x du equals 1 on x dx. dv equals dx. v equals x. And then you write it again. X ln x squared minus 2 times big brackets. What do you write?
x ln x minus the integral of x 1 on x, which is dx.
Beautiful. We're already at that stage. You can already see x, 1 on x cancels out, which is just dx. And then last line, just to have a quick look at the top, x ln x squared, yep, minus 2 times x ln x, yep, plus 2x. Well, we know that's going to become a positive x when we integrate, and then negative and negative. I think we've got it. So technically, all I will do at this stage is I will just rewrite the answer out now. Boom. Perfect. Well done. So yeah, the only way you can integrate logs, so the only way you can integrate these two, just so you guys know this, integrate logs and inverse trigs, is via by parts. So you can't actually integrate logs and inverses. We can only differentiate them, as you can see. And then somehow we use by parts to integrate them. So the integral of log, for those who are wondering, is x ln x minus x. That's how that works. All right. One more inverse question, and I think we'll do some of those harder algebraic style ones. So let's see, inverse cos, or is it a different one? No, that's it. So we'll just do an inverse cos. We'll just do this one. Let's see what happens. Inverse cos. All right, who's going to give a try with this for this one here? Again, I'll write up a few things. U, du, dv, v. What are we going to try? You know you can't integrate cos, right? So of course it's just going to go up here. And then derivative of that is negative 1 on square root 1 minus x squared dx. And then dv is just dx, and then v is just x. Okay. No one's going to give it a shot. All right, all good, all good. All right, so I equals x inverse cos x, x inverse cos x, half 0, minus, plus, integral x on square root 1 minus x squared dx. Any questions? Equals sub in a half. Inverse cos of a half is 60 degrees, which is pi on 3 times a half. So that becomes pi on 3 times a half is pi on 6. And then minus, obviously if you sub in 0, it doesn't matter what it's multiplied by, it's still 0. Plus, now this guy. Okay. This looks really weird, so I can't, it's definitely not a plus 1 minus 1 trick, because obviously there's a square root there. I guess you got to run through everything you've learnt, and I'll just wait for someone to tell me the answer or the method.
Inverse cos.
Well, it can't be inverse cos.
Oh wait.
There's an x there. Sorry, you're close. There's an x. If it was 1, it would be an inverse sine, let's say, but it's an x. So nope. Think of all the methods you've learnt in 4 unit. Just say it. Say them out loud. Say what you know. That's what you've got to do. So go.
Oh, this is the integration by substitution thing.
It is integration by substitution. It's a good guess. Completing the square? No way. I don't know, what else have we learned? Partial fractions? No way. What else have we learned? Have we done anything else? By parts? No, obviously not by parts. Wait. Completing the square. Normal, all the normal stuff, so normal exponentials, normal logs, normal trig, inverse trig, all that. No. With substitution, we've learned 3 types of substitution: normal substitution, T formula substitution, and trig substitution. Okay, I thought so. I was like, how can that be? Anyways, this is a substitution question, and which one out of the 3? Is it a trig, T formula, or normal?
It's a normal one.
It's definitely not a T formula because of the sign. It is a normal one. It can't be trig either because of the x there. What would you let u equal to, Ben?
1 minus x squared.
1 minus x squared. Now, this is something I didn't tell you guys. I said it probably once or twice, but I didn't really emphasize it because I just wanted you guys to get used to this bit here first and seeing the derivative, which is negative 2x dx. But I think a better substitution than u is to try to eliminate the square root if you can. So what do you want u be instead of u? What's a little bit better than u, Ben?
U squared.
U squared.
U squared.
Yeah.
That's
Remember, it
enough.
just becomes 2u du. So when you differentiate u squared, you would let that become 2u du. This becomes negative 2x dx. The reason why I do that is because your 2's cancel out, which makes it a little bit easier. There's no fractions. And if you want x dx, we'll bring this negative to this side. So it becomes negative u du. And look what happens when you sub this in. X dx is negative u du. That's a plus, so that just becomes negative u du all over square root of u squared, which is just u. Look how easy that becomes. There's no surds, no mess. So it's just a stronger version. U would work. 3-unit students can only do U because they don't know how to do this implicit differentiation that's only taught to 4-unit kids. But you guys will obviously look at your 3-unit questions and be like, yeah, whatever, we'll just do it implicitly and do U squared. It's a lot smarter than trying to do U. And at the same time, I guess, in saying that 3-unit students sometimes get given this, and then they try to differentiate this side, silly, what they should have done is obviously squared it to get back to here and then done implicit. So just keep in mind, you guys have been taught that, so try to apply that to your 3-unit questions when it comes up. All right, integral of du is just obviously just u plus c, and then what must we do in our final line?
I have to sub back u into the thing.
So that becomes square root of 1 minus x squared plus c. Were there limits? Oh, there were limits. Stuffed up. Here, there's limits, 0.5. So what are we meant to do with our limits? Right, we're meant to change them to u's. So when x is a half, half squared is a quarter. 1 minus a quarter is 3/4. Square root that u equals root 3 on 2. So that becomes root 3 on 2. When x is 0, u becomes 1. That's 1. Sorry, forgot the limits. Oh, if you're wondering, if I didn't change my limits, like if I did forget that for any reason, and I'm already up to this last line, if I decided to bring x's back in, then I could have chosen this limits, 0.5. So you don't need to, like if you ever do forget, you don't have to go and change everything. If you rewrite this in terms of x's, like I had just written, then my limits I could have chosen were 0.5. But I don't want you guys to get used to that. It's more because I made a mistake. Root 3 on 2 minus 1. And you're done. And our answer is what? Pi on 6, positive 1, minus root 3 on 2. Add a bit. So yeah, that was good spotting there, Ben, to realise that's a substitution question. All right. Now we'll look at some of these miscellaneous style of questions by parts. Not those ones, not 17 just yet. 17 probably will be next week when we do reduction formula. That's easy, easy, easy. Sec cube, we should do that. I might leave that for homework and I'll let you guys think about that. 24, again, we should do that. Let me just see the ones I was going to do. 21, 24, that pretty much, again, you should do that for homework. 26 is what we're going to do right now. 26 is what we will do right now. And then 29 is reduction formula, so that will be next week. That starts off our next week, and that starts off our next week. So if you want to look into these two for homework, if I don't get time today, that's pretty much going to be our starting point for next week, which will be these beautiful big monster questions. But let's start 26, and then if we get time, we'll do 21, 24, 25 first. Okay. So a little bit different, not asked as often as the ones that we were doing last week, which is all of these, by part questions and the recurring ones for sine and exponentials, like these ones here. So those ones are asked more often, but these ones not asked as often, but when asked, a lot of students have problems with them. Because I feel like if I never gave you this, right, and I just said integrate that, a lot of students wouldn't think integration by parts at first. But it's a really good skill to get used to going through all your topics and going, okay, well, is this a substitution question? Well, it can't be, because if I differentiate this, I don't even have it as an x dx there. So it's not a substitution. Is it a completing the square? No way. Is it a partial fractions? No way. So the only thing you're left with is integration by parts. And that's the only thing you have to try. So I feel like that would have been a harder question for me, just to tell you integrate square root of 1 minus x squared dx. But obviously it does say evaluate using integration by parts, so you know what you've got to do. You're just going to make sure you pick your u correctly. So let's say u dv v. All right. What does u equal to? And what does dv equal to? It's pretty obvious. But what does u equal to? Anyone know?
Root 1 minus x squared.
Yeah, you can't say dv is that, because that is the question. So u is 1 minus x squared to the power of a half. Dv is equal to dx.
Dx.
Let's continue this, Ben, then. Du is going to be half.
Cool.
And then?
1 minus x squared to the power of negative a half. And that's just times by negative 2x. And then you can just...
Okay, dx. V?
V is just x.
All right, and then I equals to x times root x. Okay, so x root 1 minus x squared. Yep. Minus.
Minus.
Now, half times 2. So look at the way I keep doing it. Half times 2. I'll cross that out. Go on. Negative plus integral x times x becomes
X squared.
And then you know that's a negative half, so all over
1 minus. Wait.
Yeah,
root
yeah,
1
right.
minus x squared.
Yeah, that's fine. 1 minus x squared and then dx.
Mm-hmm.
All right, now most students go, what? I had this and now I've got an even worse one. Made it even harder. Well, you kind of have, but you kind of haven't, because what's going to happen now is we're going to do...
Yay.
Why is this a +1 - 1 trick, Ben? Because this x squared is the same as the x squared here, same power. Keep that in
Yes.
mind. It's the only way you're going to be able to realize it. Now, a lot of students go, but then this one's got a square root. Before we didn't, and I obviously what I say is I never said anything to do with square roots. So square roots can be there. It's got nothing to do with that. It's about this x squared. This is an x
Right.
squared and a single x squared and a single x squared. The plus one's x cubed and an x cubed. It's +1 - 1 trick. Right. So this one here is not an issue. Here, you're going to make the top look like the bottom. Forget the surd. You're going to make the top look like the bottom. So you're going to make the top look like 1 minus x squared.
Yeah.
So what are you going to write? If you've got to make the top look like the bottom, what would you write?
I don't know.
You would write the bottom.
Hmm.
Hmm.
And then?
Isn't that a simple technique? If I've got to make the top look like the bottom, well, why don't I just make it the bottom?
Okay.
But is that allowed for me to just
No.
go from here to this? No. So what are you going to do
No.
now? Adjust.
I'm gonna minus the one.
Yeah, correct. That's what I mean. You're going to adjust. It's a lot easier to do it that way than trying to get from here to here. It's easier to get to here and then go back to where you're meant to be. So you didn't want the +1 here, or you never had a +1 here. So you're going to -1. You never had a negative x squared here.
Would you take
So
the
you're gonna-
negative out?
You're going to put the
Yeah.
negative out. And then, of course, all over. Is everybody else still with us? That bit there you'll get used to. As we do more and more of these algebraic by part questions, you'll get used to this +1 - 1 trick. Okay. Equals x root 1 minus x squared minus, split them up. So that becomes 1
So,
minus x squared.
Minus x squared on top of
Well, my
one.
is power of a
Yeah.
half.
Just half. Yeah, and then you can
See it is minus 1 on
on root 1 minus x squared.
root. Yeah. You guys are probably thinking, why do that? It's just I feel like it's a little bit easier for you guys to see what we're about to do with that next line. X root 1 minus x squared. Okay, these are actually the same, aren't they? So what am I
Yeah.
going to do with powers?
You're gonna minus them.
So what's this going to become?
1 minus x squared to the power of half.
Yeah, and so you just got rid of it. Look, something that was really complicated, you just simplified it and made it into a simple 1 minus x to the power of a half, or not so simple. But what is 1 minus x squared to the power of a half when you're integrating? Well, isn't that the question?
That is, yeah.
So that just became a reoccurrence. We're going to bring it over and, a repeating question. All right, anyways, we'll continue. Dx, we'll stop with that one. That stopped.
Mm-hmm.
Negative and a negative makes it into a positive,
That's
Okay.
inverse sine.
and that becomes an inverse sine. So plus inverse sine of x plus c. And then Ben, you're really one line away. That's I. That's your I. You're going to plus it over, and you're pretty much done. Which is really interesting, right? A simple algebraic 1 minus x squared to the power of a half
Turn into all of that.
turned into like an inverse sine and an x root. Yeah. So it's really weird like that. And that's how integration is. Plus inverse sine x plus c all over 2. We want to focus from this step. Sorry. Yeah, pretty much from this step. That's the most important skill to learn. I expect you guys to get this for at least another 2 or 3 weeks. Once we do reduction formula, you'll say I'm really good at this stage. Right now, it's okay. It's the beginning. But reduction formula will be all of this again and again and again and again and again. All right. Let's go one more. Let's go 1. I'll leave that one for homework because that's not too hard. Sec cubed is sec squared times sec, and the integral of sec squared is tan. So you're going to integrate sec squared, but you're going to differentiate sec. And the derivative of sec is sec tan. So that one's not that hard. I'll leave that one for you guys to try on your own time using occasion multipliers twice. Let's have a look at this one though. Okay. The integral of sine ln x dx from e to 1, from 1 to e, sine ln x. Okay, so this one here is, it's not, let's get something clear. It's not sine x ln x. That would be 2 different functions. This is signing a log. Okay, it's not sine x ln x. So you're not going to say, oh yeah, this is u and this is dv or whatever. It's not like that. This is signing ln x. Okay, so let's see. What would u be? And what would dv be? Of course, u is going to be the sine ln x, and dv is just going to be dx. Now, what's the derivative of sine? Who wants to try this? Who actually wants to really give sine ln x a real good shot? Anyone? Someone's calling. Who's calling? No? Okay. Who wants to try this one out? Sine ln x. Come on, differentiate sine. Someone, just doesn't matter if it's wrong.
Negative cos 1 on x.
It won't be negative. Hold on. Derivative of sine is going to be positive cos.
Negative cos
Try it again. Go. Cos what?
1 on x.
Cos 1 on x? No.
Would it be cos over x dx?
Cos over x dx. Cos x over x dx, is that what you said?
Yeah.
I think that's pretty close, but still not right. And you both got the same section wrong.
There's an L inside the cos bracket.
Yeah, right. You guys decided to change your angle, but the angle is a log x. So that cos is still cos of log x. That angle doesn't change, just like your exponentials. If the exponential is 2x, that doesn't change. If it's 2x ln x, it's still 2x ln x. Does not change. Understand that, Greg and Maria? Like, you can't change your angles. So that's cos ln x. That's perfect now. Then times by the derivative of the inside. What's the derivative of log? And that's when you said 1 on x, Greg, dx. So the answer is cos ln x on x dx. And that just becomes x. Any questions? Okay, next one. this times this, so that's just x sine log x with our limits of e and 1 minus x and 1 and x cancels out, so that becomes integral of cos ln x dx with, again, e and 1. Next line here, usually I would substitute this in, so e is e, log e is 1, sine 1 is sine 1. You can't really do anything with that. So this is going to become, look, it'll look like this, e, there, it will look like e sine 1. Sine 1. Then you sub in 1, log of 1 is 0, sine of 0 is 0, and then 0 times anything is still 0, so that just becomes e sine 1. That's it. When you sub this in, it'll just become e sine 1. Now this, cos ln x, well, that's a bit annoying, right? This hasn't made it any easier. You got to do it again. So here we go. U equals cos ln x du dv equals dx v equals x. All right, cos ln x. What's the derivative of cos? Sorry, yep, derivative of cos ln x. Who wants to try this one out?
Minus sine ln x dx.
Minus sine ln x, so close.
Over x,
On
right?
top of d.
Over x, yeah. You got to times by the derivative of log x, which is 1 on x, so all over x. Perfect. And look, it's going to repeat. Sine ln x, the x's will cancel out. All right, let's keep going though. E sine 1 minus big brackets, because you don't want to get this wrong. X cos ln x, x cos ln x, and then brackets here for your limits, e and 1 minus integral x cancels, that's a negative, that makes into a positive, sine ln x dx. I've got my limits 1 and e. I know this is just my I. This is just I. And there's my negative I, right? It's got to be negative. That was the clue I gave you guys. E sine 1 minus, open bracket, for this one becomes log of e. Log of e is 1, cos 1, so this becomes e cos 1. Log of 1 is 0, right? Log of 1 is 0. So cos of 0 is 1. 1 times 1 is 1, minus 1. Plus I. Next line, e sine 1 minus e cos 1 plus 1 minus I. Bring the I over, 2i equals e, and then just go back up, make sure you got the plus 1. I think it's all looking good. E sine 1 minus e cos 1 plus 1 all over 2 cross out the 2, and you are done. Now ask me any questions.
Adam had a Kogi. And
What is it? Yeah, it's probably my mistake. All right. Anyone have any questions? Good. Okay, so that was that one. 640. Look, we'll do a reduction formula question, just so you guys can see how they work. That's a harder reduction formula question than these ones would be. So Let me just pick out one. So reduction formula is usually worth, so this question itself only is worth about 5 to 6 marks in exams. The good news is you can always get 2 marks for the last one. So for part B, you can always just get 2 marks because that's just a substitution. This is what we're going to be looking into further next week. So reduction formula or formulae, however you want to say it, formula for now. Reduction formula. What is it? So it says given that j of n, so any integral, I'll just use I since I think you guys are more comfortable with I for now. So the I of n being any power of I, is equal to 0 to pi on 2 of cos to the power of nx dx. Prove this. Prove that I is equal to n minus 1 over n, and then the same I, but the power is subtracted by 2. Okay. What are we actually doing? So the idea of reduction formula is it allows us to pretty much find a formula in terms of n, so that if I want to find any power of this, I can actually just do it by simple substitution. Why? Well, if you think of cos, do you know the integral of cos x? Yes or no? Do you know how to integrate cos x? Come on, someone's got to talk to me. Do you know how to integrate cos x?
Yeah.
Do we know how to integrate cos squared x? Anyone remember how to integrate cos squared? There's a technique for it. Come on, think of trig. Cos squared. Use double angles. Right, we've got to use cos 2x. But then what about if I got cos cubed? What if I had cos power of 4, cos power of 5, cos power of 6? What are you going to do? There aren't any more formulas that you got to keep learning. And that's when reduction formula comes in and goes, okay, hold on. What we can do is we can get any power of n, in fact. I can find it for 1, 2, 3, whatever you want. You want 20, we can do it. But first, we've got to create the formula. Okay, so let's start. Okay, so you're given that In, and there's a technique for them. So given that In is equal to the integral from 0 to pi on 2 cos of n to cos x to the power of n dx. Prove that this In can be written as n take away 1 over n I to I of n take away 2. So the exact same thing with the take away 2 there, for example. Right, just let me write it up here just so you guys are familiar with that, because I know it's your first time. There. N minus 2 just means just change your n take away, change your n's to n take away 2. Just like your, I don't know, f of x. So if this was f of n, there it is, n's. If it was f of n minus 2, that means replace all your n's for n minus 2. Anyone not sure what I'm saying there with that? All right, so back to this. In is this. What your first step is, you can't, like, I mean, yeah, sure, you could have said u is this, and then dv is dx, and then you would have introduced x, and you're just going to create this big mess. What you want to do is actually split up this using index laws. So your first one is cos x, power of 1, times cos to the power of n minus 1x dx. Yep. We understand what I've done there? N is equal to 1 plus n minus 1. So I've split it up into cos x and cos n minus 1x dx. The reason why we do that is because now I can say my dv is actually cos x dx. Instead of before, what I would have written dx, and I would have introduced algebra. Whereas now, cos x, the integral of cos x is what? Integral of cos going up is just sine. And then my u is cos n minus 1x. So cos n minus 1x. Who wants to give it a shot to differentiate this? It's just chain rule. So differentiate cos x to the power of n minus 1. You might write it here. That's what that is. Come on. Who wants to give it a go? Yeah, go.
N minus 1 brackets cos x, and then it's n to the power of n minus 2.
N minus 2.
And then the integral.
See?
I mean, yeah, that is
Derivative of the inside. Don't ever forget that rule.
Yeah.
Differentiate the inside. So what's the derivative of
Sine
cos?
x.
Negative sine.
Yeah.
Good. Can't forget those rules. You got to keep saying them to yourself. Differentiate the inside times by negative sine x. All right. Now this looks like a whole bunch of what the heck, but it will work out. In equals this times this, which is sine x cos n minus 1x. You have limits, which is 0 to pi on 2, so put them in. Minus, so that becomes plus n minus 1. That's just a constant that can go in the outside. Integral sine x times sine x. Yes, sine x times sine x becomes sine squared x. This is cos n minus 2 x dx. We've got our limits. Okay, any questions before I move on to the next line? So again, this times this, limits, minus, negative, so it becomes plus, constants taken to the outside, sine times sine, sine squared, and then this. Sine 90 should give you 1, but cos 90 is going to give you 0. Cos 90 is 0, sine 0 is 0. So this whole big thing is just 0. Plus. Because in plus, as you get more and more used to, look, you only needed n minus 1. So there's my n minus 1. All right, sine squared, cos n minus 2x. That looks like a really hard integral, right? So there's no way you're going to integrate that. Think about sine squared. Where have you seen sine squared before? Sine squared x. What is sine squared x equal to? Back to your 11 trig. Come on, sine squared x.
1 minus cos squared x, right?
So you change that to 1 minus cos squared x times cos n take away 2x dx. Next line, n minus 1. 1 times cos n minus 2. We're almost there. 1 times this is cos n minus 2x minus cos squared x times cos n minus 2. What happens to your powers? 2 minus 2 cancels out, and you're left with just this. What is this? This bit here, isn't that just I n minus 2 minus n minus 1? Isn't this just in? Wasn't that the original question? All right, let's go up, have a look. The integral cos n minus 2x, as I'm saying it's in minus 2, cos nx, integral of cos nx, 0 pi of 2, is just in, and I multiply n minus 1 still, because that's multiplied by them all. Bring this over, that becomes in plus this. Factorize in out, that's what you're trying to solve for. 1 plus n minus 1. Cancel, cancel. We're left with n, divide by the n, and you are done. About 3 to 4 marks. But 3 to 4 hard marks, right? This is, we're talking about like question 7, question 8 now. The last 2 questions of the paper. So really, really top end of the state to get in this. But seriously, stock standard question. I know it looks really hard right now. If you just learn to rewrite all of that yourself within a week, you write this maybe 5 or 6 times, you'll pretty much get used to all the algebra. You'll get used to it all. And it's always the same question. If it's a sine, this will still be sine x, sine n minus 1. This becomes cos squared becomes 1 minus sine squared. Everything else starts to become exactly the same. It's the same math. Doesn't change. That's the good news, I guess. Bad news, it is long. Looks really weird. A lot of letters going everywhere. But as always, you'll get used to that. Okay. And last bit. Any questions? Seriously? No? Like, everything's making sense right now because I'm explaining, of course, but I really would like you guys to just review this again before next week's lesson. Really try to go over this. If you can obviously do reduction, then by parts is nothing. Right? You can understand this is the hardest bit. There's no reason, like I said, why anyone doesn't get these 2 marks. I really get shocked. I have some students just try to not get these 2 marks. It's beyond me. I don't understand that. It's just saying, hence evaluate. Now you can actually integrate cos to the power of 6x because you've got a formula. So the question says, double I, integrate 0 to pi on 2 of cos to the power of 6x dx. Well, you just worked that out for any n. So essentially what you're trying to find is I6, right? This is I6. The way I do it, the way I like to teach this, so again, wait, let me clear it up. There's no reason why you can't get double I, because I is always going to be a show question, so you're always going to have the answer there. So in double I, all you've got to do is just use your solution in I. So always steal these 2 marks. There's no reason why you can't get these 2 marks. Right? But here we go. So this is the way we're going to do it. I6. That's what we want to find, right? Because I6 is power of 6. Well, we know I6 is 6 take away 1, so 5 on 6 of I6 take away 2, I4. And you find I4. That's easy. 3 over 4 of I2. Look how easy this is. I2. I2 is 2 take away 1, 1 over 2 of I0. Now you don't keep going because if you get to 0 take away 2, that becomes inverses, and this doesn't really work for inverses. It only works for positive integers from 0 onwards. So I0, that's, you've got to actually find what I0 is. Well, I0 is 0 pi on 2 cos to the power of 0 x dx. What's anything to the power of 0? 1, right? So you're just going to go and integrate 1 dx, which equals to x. So what does I0 equal to? Pi on 2. Did you want I0? No, you wanted I6. So what are you going to do now? Now that you found I0, you're going to go backwards. You're going to write I2. I2 is half of I0. Half of pi on 2. I4. I4 is 3/4 of I2. And then last bit, I6. I6 is 5/6 of 3 pi on 16, which equals to what? 15 over 6 times 16. 5 on 32. 5 pi on 32. Finish. Just look at that. What I did is I started with I6, subbed it into the formula, n minus 1 on n, in minus 2, got down to I0, worked out what I0 was. The power of 0 is 1, and then just work that out real quick, pi on 2, and just go backwards. I2, I4, and eventually I6. All right. I am going to stop that one there.